Hello learners, welcome to this video lecture session. Today's topic is geothermal energy. This topic is for week 9 for the program Energy Resources and Conversion Processes. I am Subhasis Maji, professor in School of Engineering and Technology from Indira Gandhi National Open University. Dear learners, let us start our discussion on the topic geothermal energy. After listening to this video lecture, you will be able to describe the geothermal energy sources. You will be able to know the types of geothermal power stations. You will be able to explain the ring of fire, and you will be able to discuss the global scenario of geothermal energy. Underneath the Earth's hard surface known as crust is the trapped molten mass of Earth known as magma, which is present at about 3000 degrees centigrade. The curve varies in thickness ranging from 15 km to 150 km and insulates the Earth's outer surface and protects it from the intense heat of the magma. However, there are certain locations on Earth where the thickness of the crust is small, of the order of few hundred meters, and when the crust is cracked, subsoil water comes into contact with the hot matter and gets vaporized into steam or hot water. There are some locations in Iceland and in Himalayas where such natural hot water springs are found. In some other places, if we can drill through the crust over a kilometer or so, the hot matter can easily be reached, and by pumping water at pressure over this hot matter, it is possible to produce steam which can be collected and brought up to the Earth's surface and used in a steam power cycle to produce electricity. What is geothermal power? Geothermal power is a power generated by geothermal energy. Technologies in use include dry steam power station, flash steam power stations, and binary cycle power stations. Geothermal power stations are similar to other steam turbine thermal power stations. For instance, heat from a fuel source, in geothermal case the Earth's core, is used to heat water or another working fluid. The working fluid is then used to turn a turbine of a generator, thereby producing electricity. The fluid is then cooled and returned to the heat source. This is the diagram of a geothermal power. This type of scenario is there in different parts of the country that is known as Iceland. So, in the Iceland there are several geysers, there are several geothermal power stations are there, and they generate electricity. They generate electricity of 99.5% from the renewable sources like solar, wind, and mainly through geothermal power stations. Geothermal power is considered to be a sustainable, renewable source of energy because the heat extraction is small compared with the Earth's heat content. The greenhouse gas emission of geothermal electric stations are on average 45 grams of carbon dioxide per kilowatt hour of electricity, or less than 5% of that of conventional coal-fired plants. Types of power stations. Dry steam power station. This is one of the types of power stations from geothermal energy. In certain locations, dry steam oozes out of the earth and it can be directly used in a conventional steam power plant with suitable accessories. Dry steam power directly uses geothermal steam of 150 degrees centigrade or greater to turn turbines. The steam coming out of the geothermal well is carrying with it liquid water, sand and soil and dissolved material matter from earth. These need to be separated before steam is fed to the turbine. Otherwise, the life of the turbine blades will be very much reduced due to erosion. The exhaust steam from the turbine is condensed in the condenser and the condensate is either re-injected into the hot geothermal zone or used for preheat in process industries. This is the diagram of dry steam power stations. Now you see that the dry steam is directly tapped from the producer well and that steam is used for producing electricity through turbine and generator. And after the expansion of the steam in the turbine, the low pressure, low temperature steam is again sent back through the injection well from where it was tapped. Flash steam power station. This is another type of power stations for using geothermal energy for producing electricity. These systems are employed in regions where hot water at high pressure and steam are received from the hot zones. This hot water is sent to a flash chamber which produces steam at slightly lower pressure and temperature. This steam is used in the steam power cycle. Flash steam stations pull deep high pressure hot water into low pressure tanks and use the resulting flash steam to drive turbines. They require fluid temperature of at least 180 degrees centigrade or usually more. This is the most common type of stations in operation today. The hot water flows up through wells in the ground under its own pressure. As it flows upward, the pressure decreases and some of the hot water boils into steam. The steam is then separated from the water and used to produce power turbine or generator. Any leftover water and condensed steam may be injected back into the reservoir, making this a potentially sustainable resource. Any leftover water and condensed steam may be injected back into the reservoir, making this a potentially sustainable resource. This is the diagram for flash steam power station. You see, through the producing well, steam is coming and it is entering into the heat exchanger and heat is being transferred to the water which is there in the steam turbine process, and the heat supplied to the water producing steam, that steam is being utilized for the expansion through the turbine for producing electricity, and the shaft of the turbine is coupled with the shaft of the generator, which in turn produces the electricity. There is another type of power stations known as binary cycle power stations. Binary cycle power stations are the most recent development and can accept fluid temperature as low as 57 degrees centigrade. The moderately hot geothermal water is passed by a secondary fluid with a much lower boiling point than water. This causes the secondary fluid to flash vaporize, which then drives the turbine. This is the most common type of geothermal electricity station being constructed today. The thermal efficiency of this type station is typically about 10 to 13%, and the binary fluid is generally butane or pentane. This is the diagram for the binary cycle power stations. Here you see that through the producing well, the water which is there at a high temperature and pressure, it is being tapped and entering into the heat exchanger, and heat is transferred to the binary fluid which flows through the main cycle with producing electricity. Now the question is, where is geothermal energy found? Found along major plate boundaries where earthquakes and volcanoes are concentrated. We will get geyser, hot springs, fumaroles and geothermal reservoirs. Sources of Earth's internal energy. 70% comes from the decay of radioactive nuclei with long half-lives that are embedded within the earth. Some energy is from residual heat left over from Earth's formation. The rest of the energy comes from meteorite impacts. Now let us discuss about geothermal energy sources. Hot water reservoirs. As the name implies, these are reservoirs of hot underground water. They are more suited for space heating than for electricity production. Natural steam reservoirs. In this case, a hole dug into the ground can cause steam to come to the surface. We have discussed this type of power stations known as dry steam power station. Then geopressurized reservoirs. In this type of reservoir, brine completely saturated with natural gas in stored under pressure from the weight of overlying rock. This type of resource can be used for both heat and for natural gas. Normal geothermal gradient. At any place on the planet, there is a normal temperature gradient of plus 30 degrees centigrade per kilometer dug into the earth. Therefore, if one digs 6,000 meters, the temperature will be about 180 degrees centigrade above the surface temperature. Hot dry rock. It is similar to normal geothermal gradient, but the gradient is 40 degrees centigrade per kilometer dug underground. Molten magma. No technology exists to tap into the heat reserves stored in magma. Now let us discuss about a very important topic, that is the ring of fire. Geothermal energy can sometimes find its way to the surface in the form of volcanoes and fumaroles, hot springs, geysers. The most active geothermal resources are usually found along major plate boundaries where earthquakes and volcanoes are concentrated. Most of the geothermal activity in the world occurs in an area called the Ring of Fire. This area rims the Pacific Ocean. So this is the map for India where the geothermal energies are having. Say for example in the Himalayan range, in the near West Bengal or near Delhi, there are geothermal sources of energy. So if you visit to the place known as Bokkesar near Calcutta, you will find there are several hot springs are there where hot water is coming out. Or if you visit to Kullu Manali, there is a place known as Manikaran. There you will find hot springs, and in that hot springs people use for making the rice. The rice has been cooked in those areas where they will put the rice in a cloth and put it in the hot water for some time, and after that the rice will be cooked as we cook at our home with the help of pressure cooker. Scenario of geothermal energy in India. India has reasonably good potential for geothermal. The potential geothermal provinces can produce 10,600 megawatt of power. Though India has been one of the earliest countries to begin geothermal projects way back in the 1970s, but at present there are no operational geothermal plants in India. More than 300 hot springs locations have been identified by Geological Survey of India. The surface temperature of hot springs ranges from 35 degrees centigrade to as much as 98 degrees centigrade. These hot springs have been grouped together and termed as different geothermal provinces based on their occurrence in specific geotectonic regions, geological and structural regions such as occurrence in organic belt regions, deep fault zones, active volcanic regions, etc. These springs are grouped into 7 geothermal provinces, that is Himalayan basins, Sahara Valley, Cambi Basin, Shan Narmada Tapi, Lincement Belt, West Coast, Godavari Basin and Mahanadi Basin. Now let us discuss about the potential sites for geothermal sources in India. Puga Valley, that is located in J&K. Tatapani, that is located at Chhattisgarh. Godavari Basin, Manikaran, that is located at Himachal Pradesh. Bokkesar, that is located in West Bengal. Tuwa, that is located at Gujarat. Unnai, located at Maharashtra, and Jalgaon, located at Maharashtra. These are the places where there are sources for geothermal energy. Geothermal energy is thermal energy generated and stored in the earth. India's installed capacity of geothermal energy is experimental and commercial use is insignificant. Geothermal energy is thermal energy generated and stored in the earth. India's installed capacity of geothermal energy is experimental and commercial use is insignificant. According to some ambitious estimates, India has a potential of 10,600 megawatt in the geothermal provinces, but it still needs to be exploited. India has potential resources to harvest geothermal energy. Now, there are several geothermal research centers in India. MSSY India. MSSY India acts as technical arm to governmental institution in the conduction of scientific and geothermal research projects and stimulates new research and development projects in collaborations with Indian national research institutions and international organizations. in particular in the field of techniques and earthquakes mechanisms. In the field of techniques and earthquake mechanisms, reservoir-induced seismicity, advanced mining technologies, groundwater production stimulations, use of geothermal energy, hazardous underground waste storage, Geological Survey of India, National Geographical Research Institute located at Hyderabad, and Oil and Natural Gas Corporations located at Dehradun. These are the research institutes located at different parts of India for conducting the research work for exploring the possibilities of energy through geothermal sources. Now let us discuss about the advantages of geothermal energy. Geothermal is a reliable source of renewable energy. Geothermal energy also has many advantages when compared to other renewable sources like solar, wind or biomass. It is an exceptionally constant source of energy, meaning that it is not dependent on neither wind or sun and available all year long. When looking at the availability factor, which shows how reliable and constant specific energy sources are, geothermal is ranking on the top, way above the other groups, which supports the argument of its independence on inconsistent external circumstances when delivering energy. There are some disadvantages of geothermal energy. Environmental concerns about greenhouse emission. Unfortunately, no matter its reputation of being an environmentally friendly alternative energy source, geothermal energy also causes some minor concern in regards to the environment. The extraction of geothermal energy from the grounds leads to a release of greenhouse gases like hydrogen sulfide, carbon dioxide, methane and ammonia. However, the amount of gas released is significantly lower than in the case of fossil fuels. Possibility of depletion of geothermal sources. Furthermore, despite being considered a sustainable and renewable energy, the chances are that specific locations might cool down after some time, making it impossible to harvest more geothermal energy in future. The only non-dependable option is sourcing geothermal energy right from magma, but the technology for doing this is still in the process of development. This option is what the investment mainly thanks to the fact that magma will be around for billions of years. High investment cost for geothermal system. Another disadvantage is the high initial cost for individual households. The need for drilling and installing quite a complex system into one's home makes the price climb quite high. Another disadvantage is the high initial cost for individual households. The need for drilling and installing quite a complex system into one's home makes the price climb quite high. Nevertheless, the return on such investment is very promising, being able to earn the investment back within 2 to 10 years. Now let us discuss some more advantages and disadvantages of geothermal energy. Advantages are theoretically inexhaustible energy source, often an excellent supplement to other renewable sources. does not require structures such as solar panels or windmills. Energy is continuously available and more dependable than solar and wind energy. Capital and running costs are lower compared to nuclear and coal-based thermal power plants, less polluting compared to conventional thermal power plants. And let us discuss about the limitations of geothermal energy. Dissolved solids in water steam poses problem of separations. Complete separation of solids is not possible and hence restrict the life of the turbine blades. May cause ground surface or ground water pollution if effluents are not injected back to the earth. Not available in many locations. Not much power per vent. Dear learners, we have discussed in detail about the geothermal energy. Let us very quickly summarize our discussions. We have discussed the geothermal energy sources. We have discussed the types of geothermal power stations. We have discussed the very important topic, that is ring of fire, and we have discussed the global scenario of geothermal energy. Lastly, we have discussed the advantages and limitations of geothermal energy. Thank you very much.